Alright, we are live. Hello everyone and welcome to today's live stream where we will be going over several experimental branches that are currently for Blender 4.4, but that doesn't mean that the branches will be implemented in 4.4, they're just experiments. So today, right now, we'll try out the NPR branch, the Non-photorealistic rendering branch, the Voronoi fracture branch, and the rigid body dynamics branch. So first we'll start out with the NPR branch. So with this one, we can see here that the material output has a new option. So we'll click on that and then go over to the NPR tab right here. And we'll see that there are absolutely no nodes. So we had to add in the input, which in this case I'll put in the NPR input. And then the output needs to be an NPR output. But you do get AOVs, which is very nice. This is being developed by Delingo, I believe that's the name, who made the goo fork of Blender, the goo renderer, which is used for a lot of cell shading and stuff like that, which is very cool. So right here we can see that we have the combined color and then the color output. I'm also going to turn off the previews just because we don't need them and it may cause a crash later on. So here we can see we get the diffuse color, the diffuse direct, diffuse indirect, specular, and all that. Since I'm using a white material, we can't see all too much, but some really cool stuff can happen when we start playing around with this, particularly when we use NPR refraction, which is another very nice input. So here we have NPR refraction, and to get this to work, we need to turn on ray traced transmission, and also ray tracing, or in this case, screen tracing. So here we can get the, oh, and by the way, if you see that, that's because I tried using Node Wrangler to connect the output to the input, or the input to the output, and that just does not work. So here we can see that if we take the combined color and output that, then you get the, basically what would happen if you had refraction. Now shadows are currently working, which I need to, oh right, in AV Next there, you need to disable the shadows manually. There's not just an easy checkbox, but we'll ignore that for now. So here we can get the position of the stuff inside of this volume and the position of the surface of this cube, which means that we can do some very interesting stuff. I haven't had too much time to play around with this, but from what I've seen, some cool stuff can happen. So here we can get the distance to anything inside of there, which is cool. I've seen games in the past use this for, well, a lot of things like shields, where you can see like a little line at the beginning where it starts, for oceans and all that cool stuff. So let's just do a very simple setup where it will mix the colors between the, the transmission color and a color of our choosing, and we'll use a map range to use the distance to switch between those. Let me connect this to the output. And here we can see we're getting kind of a fog-like effect, which is quite cool. And let's set this to be blue. So if this were an ocean or water, we would see that it looks pretty nice. Now again, the shadows are affecting it immediately, which I will try to disable. Let's see how transparent shadows, if we turn that off, nope, that still exists. I forget how to do the shadow, no shadows on EV Next, which I think if I use an is camera ray, no, not camera data, light path node, I forget, doing it in EV Next is a little bit funky. Let's use the mix shader and then just have transparent. Here we go, and if it's a shadow ray, yes, I think this is how you do it. Okay, EV Next shader compilation is being a little bit gimmicky. There we go. I don't think there's any shadows here. Yes, okay. So that's how you turn off shadows in EV Next. Let's go back to the NPR part of it. So we have the distance, and as we can see, the distance is causing this to look like a kind of, you know, like water that fades over time. There we go. That looks pretty good. But we can do some other cool stuff. Like if we take the position here and then put it into a checker texture. Wait, where's the checker? Texture, checker, there we go. We connect that into there. We can make it so that everything inside of the cube has a different texture, or I'm not sure if we can change the shader, but we can play around with quite a bit. So here we can do that, and we can do that. One thing that I wanted to try was using the refraction normal and comparing that with the NPR normal, but unfortunately it does not look like we can do that yet. Again, this is an experimental branch. We don't know if/when it would be coming into Blender, but it is very fun to just play around with. So in this case, I can make it so that this mixes between, let me connect this to the output, a checker overlay and just the regular texture, which is very cool. I've seen someone mention to me that this could possibly be used for decals. I have not tried that yet, but that sounds like a very, very cool idea. Actually, do I have... Let me just make a decal of my own. Let's see. Do we have access to the UV maps? We get the combined color, which means that I could get the UV map. Oh, yeah, we can do that. Okay. Let's get just the combined color here for the surface of the object. And then we can go and make a nice little decal, and then... Yeah, I think I could possibly get this to work if I think about it correctly. If we have black as just the transparent, yeah, no, that should work. Okay, let's give that a go. So let's just get the UV map, get the distance, and then warp that with just like a noise texture. So noise, set it to be 2 dimensions of noise. Let's turn normalize off. Add this to there, make sure this is set to 0.5. And let me just go and make this a plane instead of a cube, so that we can get a very nice normalized UV map. Yeah, there we go. Okay, there's that, then there's that. Then we'll multiply the noise and put that into there so that we can warp the gradients. There we go. I just want a nice little splat-like texture. Let's go and make it a little bit bigger. Maybe turn that down by a bit. And let's use a greater than node. There we go, that's looking all right. No, let's make it a map range. Let's try to make it look a little bit more special. Set it to be smoother step. Make it so that the white parts are like that, and the black parts are not. Let's see. Again, I'm not experienced with doing any of this. I'm just testing out some stuff. If we do that, we can get all that. Do we have access to the emission? Because maybe I can use that as like an alpha pass. I don't want that to be that. I want it to change that. There we go. Let's change this to be a nice color, like maybe blue or red. Let's change this to be color, swap that with that. There we go. Let's make that part red, and then the other part black, and swap those around. There we go. Okay, so we have that. Now let's try to make this into a decal. Again, very hacky. Haven't done this before, but let's go and give it a shot. So we have the combined color, and then we can separate... Wait, the diffuse. Yes, let's use the diffuse. Separate. And unfortunately, we cannot search from the image sockets. I really hope we get these, or a texture socket in the regular shader editor, so that with the textures, stuff like that, the image texture, there we go. We can go and plug in textures to there. But that would be a single value, while in the NPR part, let me also turn off shadows once again. In the NPR part, these are not singular values, they're, you know, actual pixels. Okay, so we have that. Let me just delete all of you. Let's take a look at the X gradient. There we go. So we can use that to mix between different colors, or different images in this case. So we'll switch between the regular image and then that image. Or no, the combined color image. There we go. And here we can see we have a very hacky... Well, no, that just looks like transparency. I am forgetting how decals are made. I should have looked that up. If I take the position, and then... Wait a minute. I can... Oh, wait, I can apply the texture to the actual position here, and then localize that to this object's position, and then maybe that would work? I don't know, maybe I'm thinking way too far ahead. So here we would... Oh wait, no, I want a noise, not a normalize. So let's get a noise... Actually, let me just go and copy what I have in the regular object shader. and then go back over to NPR. I think I can, yes, I can copy them between the different editors. Put that there, connect that into there. And then we can use the distance to mix between the different shaders. So here, we'll go and make it so that I'll switch between the combined color and whatever color I choose here. Nope, we want to flip that around once again. There we go. So here we can see that that part is now decaled onto there very, very well, as you can see. But yeah, I would need to offset that by the object's position, which how would I get that into there? Probably by comparing the two. No, that sounds like a bad idea. Maybe I can have the diffuse color be the position of the object and then subtract the position based off that. That might be an idea. So let's go and try that. Let's go and get the object info, location, put that into the diffuse, and then go over to NPR and then use that diffuse color to subtract or add. Wait, why can't I search the vector math subtract nodes from there? I do not know. Anyway, let's go and do that and see what happens. Do that, wait for it to cook. Nope, add. Does this affect it now? Okay, it is moving, but almost the exact opposite direction I was hoping for. Yeah, no, that's a little bit... Oh, wait, is it clamped? I think the colors might be clamped. Ooh, that kind of sucks. Or no, that doesn't make sense. Let's take a look at the image and see what's going on. Yeah, that maybe the diffuse color is clamped, like they can't go into the negatives. The positives are working just fine. Subtract, take a look. Yeah, that part, okay, that part's working fine. It's just when you go into the negatives, it dislikes that by quite a bit. Let's go and connect this back to the output and take a look. So if we do that, we can see that that's moving. That looks like a decal to me. And then if we do that... Oh wait, let's go and move this over because the coordinates are a little bit funky. There we go. Now we have somewhat of a decal. Then there, yep. That is looking more like a decal, but we can't go into the negatives, which is quite annoying. Change this to be more like that. Lift it up. And then that'll only appear there, which, yeah, I think makes sense for decals. Potentially. I'm not well versed in that. Okay, but that's cool. It only looks through the kind of portal. Okay, what other things can we do? I want to compare the normal to the position, or the localized position. Well, let me try that. Let's go and delete this, bring this back over to here. Let's connect that to there. And I'll turn this back into a cube so that we can see some other cool stuff. So here we get the difference between the refraction, or the, I guess, transparent world, I guess, position, and then the NPR, the actual object surface position. But I'm not really seeing... Ah, there we go. There we go. We're seeing that, which is very cool. I wonder what we could do with that data. Let's use another checker texture just to see what it looks like. Let's go and take a look. Let's see, what does NPR mean? It means non-photorealistic. Basically, instead of trying to get like the, I don't know, super accurate subsurface scattering and metallic and all that cool stuff, you're basically saying, hey, take the pixels, mix them together, disregard any like real life values. Which is why this is like, I guess, almost like a compositing step rather than a classic Blender shading step. Because we're just taking the output and then mixing that together. Let's see. Hey man, how's it going? It's going well. It's going well. I had a bit of time, so I was like, you know what? Let's go over the branches because all that's been pretty cool. Some very cool stuff is happening. Let's see. The normal... Oh, what if I dot product? The, that with the normal. I wonder what would happen. I should probably normalize it. Whoa. That's unexpected. And it's not changing at all. That is extremely... That almost looks broken. I do not know why that is happening the way it is. Oh, wait, I know why. I know why. That is the HDRI in the background. If I take that out, everything... Okay. We take a look at that. Wait, why is the normal output HDRI? Oh wait, do transparent things just not have normals whatsoever? No, they have to, because we have all the other shading steps. So maybe that part is just broken. Or I'm misunderstanding it. Quite a bit. We get the combined color and all that. I could just put the normal into the diffuse color and then call that a day. So let's go back into the object version. And then, yeah, that's that one. That's the object location. Let's go and get the geometry normal. Just, you know, we can put some other data out through there. We don't get a lot of low-level stuff in the shader editor, like really low level, so any additional functionality is appreciated. So we can get that normal and put that in there, and then, yeah. Let's go back into the NPR part. We can get the combined, or the diffuse color, because that's like that, and then we can use that for that, and let's take a look. Okay, that looks pretty normal to me. But what if we were to turn off the normalize? Look at it. So here... Oh wait, does that just give us the distance? Ah. Interesting. And we don't get the negative normals because it's the diffuse color output. Okay. I feel like there's a lot more that you can do with that if you, like, play around with the math a bit more. But for just a branch... Oh, and also, I forgot to mention, there's some other cool stuff. There is the image sample node right here, where you can take the output, which in this case will take the combined color of the refraction, and we can offset that by a vector. So let me just use a combine XYZ node. So we can offset that to make a kind of pseudo, like, weird refraction, which could be good. Like, this could probably be used for, like, rim lights, which I think would be a good version. Oh, and you can offset by pixel distance or by view distance. So if we go back here, the offset appears to be more because there are less pixels for the kind of surface area. But if we use it by the view, and then we set it to be 0.5, we can see that it looks pretty much very close to the same. So in this case, how would we do a kind of rim light effect for all the objects inside of it? How would we do that? Maybe... Okay, let me try something. So we'll just have the base color like this, so that potentially we could select some stuff from there. Let's go over to the NPR parts. And if we go and get the distance between the two here... Oh, and I keep forgetting that Node Wrangler does not work in this branch, or in this little area. I'm actually not sure what this node setup is made out of, because it has most of the nodes, but it's kind of treated like a node group. Let's see. Okay, so if we get the distance, and then we offset that distance, which I guess is technically... Does that work, or is that an invalid? No, okay, that does work. That's good. So we can take the distance... Yeah, we can subtract the difference between these two. No, I want a regular subtract. There we go. And we can connect that to the output, and let's see what happens. Nothing. Does that not work? It does not appear to be working. Dang it. Well, I could offset... Yeah, no, I can just circumvent that by offsetting the images and then doing the distance in post. So instead of doing that there, we just go here, and then we just offset both of these positions, and then we can go and compare the new offset parts there. So if we do that, then we should see one part is offset. We can compare the distance between the two. Then we should get something interesting looking. So if we do that and then offset... Ooh, wow. Okay. That is something. It is very interesting. So let's go and make it so that almost the entire world has this. We can offset this in pixels, so if we switch that to be like that, we can make it so that... Oh wait, we can do like a normal map. We can make our own bump to normal setup. Which I don't know why you would want to do that in this case, but that is interesting. So we offset it there, and then we can offset it up top to get that. Very, very interesting. But there, you can see how you can probably use this for like a curvature map or something along those lines. I'm not sure, I don't think there's a blur method. But there is potentially... Oh wait, is that just a singular value, or could that be multiple values? I do not know. Let's use a white noise texture. And then we'll put the position into there. 3D, yeah. Let me subtract by 0.5 so that it'll be a non-normalized result. Scale that, and then we will offset these by that. I hope this works. And then... Unfortunately, that does not appear to be working. Let's go and take a look at all the outputs just to make sure... Oh. Wait a minute. Does white noise not work? Or am I missing something very, very obvious? Well, I could just go and use a regular noise texture if that is the case, but maybe since it's an image with actual pixels, it is a very stable result. Like there, if we just scale it up, that looks almost like... Yeah, that's noise. So why isn't the white noise texture white noising? Or no, wait, it is. Okay. And what was up with the color? Yeah, what? Wait, what is going on with the color there? Okay, no, the color... Okay, no, that was working. I don't know what I screwed up. And then we can scale this, and then the offset, we can plug that into there. But does this work with non-singular value offsets? Okay, no, it... Wait, what did I get wrong then? Maybe it just had to be a value over... Oh, of course, it had to be a value over 1 pixel. Okay. I just forgot that I changed this to be pixel values instead of view values. Okay, I was being a little bit dumb. But here we can see we get the curvature mask. So if a blur node... Actually, is there a blur in here? No. If a blur node comes out in the future, that could be used for handy-dandy outlines. I guess you can do that in the compositor anyway. Yeah, what am I talking about? But this could be used for, like, you know, a filter over it. The line between the compositor and this, for me, is a bit blurred, just because I'm not familiar with it. So outlines like this, you know, you can just do in the compositor with the actual blur nodes. But you can make this like a sharpening mask, which could be cool. So yeah, if you know, there are lots of cool things you can do, and I need to discover all of them when this starts to become finalized. Yeah, tons of cool stuff. Let me read the chat real quick. Here we go. Okay. This is incredible. I'll be able to make terrain blending shaders more easily. Oh yeah, terrain blending shaders. Yes. Yes. But they would need ray trace transmission on. But yes, terrain blending and object blending, that could be very, very cool. I missed the live stream. Is this parallax in Eevee? No. There was a branch where there was like a parallax occlusion mapping shader in Eevee for like 2 years ago, which was was an experiment for Eevee Next, but that never came around. Let's see, bro, do you know how to take the tangent normal of an object without UV from the object normal somewhere else? This is related to the high-low bake through the ray portal node. The tangent normal of an object without a UV map. Maybe? Depends on what you're using it for. Let's see. Why did it never come around? I want parallax and Eevee. I think due to a lack of time, Eevee Next had quite a few delays, so their time for them is very, very precious. So anything outside of the bare essentials, I don't think will be getting a lot of attention. Like I think last time I checked, they're trying to get the shader compilation times back down to normal levels. So that'll be taking up a lot of their time. Let's see. Okay. This is absolutely crazy with nodes. I wish I had a fraction of this guy's brain. Well, right now, like, I'm just playing around with it. Like, I'm not very experienced with, like, the shader portion of, like, these kinds of non-photorealistic effects and, like, post-processing. Which, if I were more experienced with Unity and such, I probably would do that, but I've been a bit too busy to do all that. Let's see. What's this NPR space you're working in? This is one of the experimental branches. The people behind the Goo branch of Blender that does a lot of like cell shading and non-photorealistic effects are collaborating with Blender. I'm not sure how much and to what extent on a branch that could lead to very cool non-photorealistic effects down the line, maybe in default Blender. So that could be cool. From what I heard from some people that use the Goo branch of Blender, it is only in Blender 4.1 because, well, Eevee Next changed a lot and it hasn't been updated. So maybe this is like the updated version of it, I do not know. But if they're working on it, then that means we'll be getting a lot of cool stuff that people have used in like actual setups. Let's see, what else? Oh, I should also mention that I've been showing off the one trick with the like the refraction version, but you do not need the object to be refraction based for it to work. It could just be a normal object. Let's add in another NPR output. And I've not tried AOV outputs, but those should work. So you could have just an object that is solid and then have that as the output. And you may be wondering, and this was brought up in some of the developer chats, why is this like a new node editor, or I guess new in quotes? Why is this a new node editor instead of like a node group that we just put here and then output? And I'm forgetting exactly what the dev said in response to that, but maybe you want to have one setup that works on multiple materials and you don't want it to like bog down the calculation. And I guess also, since it's just taking the images... Actually, I would have to take a look at that to give an accurate answer. Is this Eevee or Cycles? Eevee. As far as I know, it does not work in Cycles, but in theory, it should be able to. Potentially. Maybe. Actually, with transparent objects, probably not. Like... Yeah, I do not know. This is if you can't tell, I'm not very experienced with this part of it. Okay. So, in this case, if you want like a special shader effect where it's like, oh, let's take the... Actually, we don't really have the... We have the normal, so we can dot product that and maybe get a Fresnel going. But if you want to make a kind of cell shaded result... Oh, yeah, why... The normal may be a bit broken in this current branch, because I'm pretty sure the normal should not be outputting the world texture. I'm pretty sure. Because that's the tree HDRI in the background. And I think that was working in a previous one. But yeah, lots of cool stuff, and I've only scratched the surface. But I think that's enough for now. Yeah, I think that's enough for now. I think we'll switch to the next branch. Let me just read the chat to make sure I'm not missing anything. So let's go and bring this over to here. But yeah, I really like this kind of distance output. I'll need to play around with this off stream to find out all of the cool possibilities, because I've only scratched the surface. Let's see the Voronoi fracture. Yes, we'll do that next. When I was thinking about the GPU accelerated geometry nodes work, one thought was that the compute shaders would have their own shader editor like this. Yeah, that could be interesting. Like, there was one, I forgot what we did, like, years ago, me and a buddy of mine, I think they found a way to make it so that whenever you would render an image, that image would get fed back into the shader system. So you would have an image texture that would read like, oh, image.001. Let's get an image texture. So you would have that, and then the previous frame's image would go into there. So it would create a buffer. And then that buffer would be used to make quote-unquote simulations, like the simulation zone inside of the shader editor, which was very cool. It had limitations, you know, with it only being able to be done when you're rendering. It would store it because, again, it was a render result, which is very cool. But maybe, you know, just maybe a more advanced version of that could come out. I know someone mentions, like, maybe buffers could come to shader editor. Well, I don't think that was a developer. I think that was someone wishfully thinking. But yeah, compute shaders. Lots of cool stuff with compute shaders that could be done. Okay. I don't know how far they got with parallax 2 years ago, but 4 years ago, some guy all alone made the best parallax branch, in my opinion. That might have been the one that I was playing around with. Dang, 4 years ago. Yeah, you forget that Eevee Legacy is like 5 years old at this point. And it still holds up. Like, when Eevee Next was having lots of stability issues, I would just use Eevee Legacy because it still holds up. Even though it didn't get like a ton of updates, like vertex displacement, that we had to wait for Eevee Next for that, and a lot of other things. It was still very, very good. Okay, let's go and switch to, bear with me everyone, we'll be switching to the Voronoi fracture branch. So let me go and open that. Let's see. I need to put all of the branches in a better place, because I have a lot of them. Okay, and if you have any questions, just let me know. Even if it's still with the NPR stuff, I can go back to that if we need to. Okay, the Voronoi branch is loading, but for some reason it's taking a while. Oh, please tell me I didn't break it. Okay, good. It's loading. Okay, let's wait for it to load. It is taking a little bit. Okay, looks like we're almost ready to go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There we go. Okay. So, this is a branch where someone has been working on a Voronoi node. So in this case, it takes points, or sites in this case. I think that if that was points, it would be a little clearer. Like, this, again, is very early on. And if you do that, let's go and randomize the position. Let's go over to here, random value, and we turn this up. We can see that we're getting kind of Voronoi cells. Turn on boundary, and then you can see, oh wait, this is Voronoi cells. That's very cool. And then you can change them to instances by doing this, even though you don't get the cell centers when you do this, which is very unfortunate. If I were to give some feedback on this, it would be like the strings to curves node, where you have the outputs, the instances, and then maybe just the actual geometry. But with this, let's just type in some characters here. When you, like, rotate instances like this, it would rotate from the center, or wherever the center point would be. I think it would be easier to do that under the hood in this node, rather than having to do it in post, because matching the indices and all that is a huge pain. You can center all the Voronoi stuff by subtracting the cell centers, but then putting that data back onto the instances is difficult from the little bit I've tried. So just having it there by default may be a good idea. If it's possible. Like, I do not know. I haven't looked under the hood, but I would assume it's easier to take the point position and then put that onto an instance rather than having to do it in post. It would probably be faster. But we'll get into that later. So yeah, having that would be useful. Kind of like the old cell fracture add-on. It would output a ton of objects, which in GeoNodes would be instances with their centers all automatically where they should be. But here we can see, we can turn this up by a lot, so that's 1,000 points, where a previous geometry node version would just completely freeze up at that point. Like, that's a lot of fractured cells. And as we can see, it's only 53 milliseconds, but turning them to instances takes longer, which is a little unfortunate. But again, this is rather early on. I really like how this looks without the boundary, because you can't do that in the old cell fracture version. That is very, very cool. So, actually, wait, let me Control-Z and put this back to instances. So if we scale instances, we could... oh, wait, no, the origin points do not work like that. So if we do that, yeah, it's not on the instances. That needs to be converted, which I've tried a couple methods, but it's a little... I need to figure that out properly. Okay, well, we could take the bounding box data and then do that. I could try using a for-each loop to do that. Actually, wait, no, we don't have... I'll need to think about that really quickly. But there's some other cool things we can do with this. So let's go and take a mesh circle. This is one example I saw the developer make. And then we can go and transform the geometry and then join these two together. And you can make a kind of boundary. Let's see. Let's turn the boundary off. Let's move this over and then rotate it. Let's see, which one was it? Boundary? No. I'm forgetting how this was done. Group by... Oh, there we go. Group by edge. So you can get a kind of... There is a way to use this at, and I'm forgetting how. As we can see, these two circles, their kind of intersection point, becomes an actual mesh, this is very cool because we don't have too many, like, just mesh creation tools yet. That probably will be coming when the lists come about, but we'll see. But yeah, I need to try out more about that. Actually, let's go and just instance a ton of mesh circles in random orientations, then see how that looks. It might crash, I don't know. Let's go and try it. Instance on points, and then we'll go and realize the instances, put that in there, randomize the rotation, random value, and then random scale. Let's change that to be a float. We have all those, let's randomize all of that. Again, we'll see what happens. Let's change that to be 5, just in case. So let's go and put that into the sites. Interesting, interesting. We're trying to get very cool and quirky results. Let's go right over to here. Oh, that's interesting. Let's go and randomize that a bit more. It's very performant compared to the geometry nodes versions we've had in the past. Look at that, that is interesting. And I don't think you would be able to split these ones into instances, which is why we probably only have the... Actually, maybe. Actually, no, you would. Because, yeah, no, these could be turned into instances, potentially. To instances... Let's see, let's go and take a look. Group ID. Oh, wait. Let me change that back to instance layer. Okay, no, we do have that. Also turn on attribute text. Ah, yes, because they're not center, because their center is 0, 0, all the numbers appear right there. But yes, those could all be split into individual instances. Let me use the scale elements node. Because with that, oh wait, the selection, yeah, no. I am forgetting, I could use the accumulate field node. Oh wait, accumulate field, there we go. We can set that to be that and an integer set to 1, and we can use the cell ID to average all the... Wait, no, we already have the cell centers. Okay, there we go. I can just mix between the regular position and then that position to get something along those lines. Oh, whoa. Funky. I like it. Interesting. Let me turn on AO. And it'll take a second. Okay, there we go. Oh, that is very interesting. I did not expect all the ribbons to be kind of sliced like that, but that is cool. Probably because, yeah, the mesh circle has a lot of those. If we do that, this is very cool. Very cool. If we turn off the group by edge, we can see that happen. Okay, yeah, we can see the Voronoi cells a little bit better like that. And we can set the boundaries. Very, very interesting. Very, very cool. So one thing, oh, that is a very interesting pattern. Wow. That would be a cool environment. Let's see, periodic. If we turn these on, then we should see that the cells extend the bounding box boundary, which is also, this looks so cool. Yeah, we need this node. We need this node. Look at that. It's, again, very performant. Like, this took, well, okay, when it's this big, it takes, you know, that much, but you want to pre-calculate this anyway. Let's see. Let's see. It's great to see that the Voronoi is being tested. I love the real-time feedback from users. Oh, wait, did you make the branch? Oh, that's very cool. Yeah, this is an amazing node. Like, we've had geometry node versions in the past that unfortunately are very slow because they, you know, code will always be faster than nodes, and it was using the repeat zone. It was before the for each loop and all that. But yeah, this is very cool. The one feedback I do have is that putting the cell centers onto instances is a little bit difficult. Which, maybe that's just because I haven't experimented enough with it, but that would be my one piece of feedback. But it is amazing. It is absolutely amazing, don't get me wrong. So if we have like a random value, let me get a random value node. Random value, let's go and put that there, set it to be a vector. Let's go and do that. Let's go there and there. Uh-oh. I was like, why is it lagging? It shouldn't lag. Oh, that is a lot of points. Okay, let me turn off the viewer and then turn off attribute text. Yep, that's why that's off by default. That's why it's off by default. There we go. Like, look at that. That is amazing. Yes, I've had similar feedback from the pull request. I'm considering the change. Yeah, that's yeah, this branch is amazing. Look at that, the colors. Okay, let's see what that looks like in the shader. Let's set that to be vector. Okay. It's very cool having a dev in chat. It's always cool to see. Okay, oh wait, why did I delete that? There we go, let's put that there, and then, yeah, we can do that. Let's go into the shader editor. Oh wait, but I haven't assigned a material. Let's go back into GeoNodes, set material, Let's go to the shader editor again and take a look at that random attribute. Let's set it to be random. Yeah, and I've been waiting to use this on the rigid body branch, which could be really cool. And also, by the way, you know, right now we can turn these into separate objects very easily. We just go apply this, and then, oh, wait, Control A, apply it, and then separate by loose parts. And then we have a ton of objects that we can then just port into the rigid body system. And I haven't used the for each loop to make tons of rigid bodies from that, and I'm not sure if that would work or crash. I would assume it works, because that should be fairly simple to do. I think I may regret clicking separate by loose parts. Well, yeah, let me catch up on chat since we have time while my computer is slowly dying. Let's see. Okay. I only see the be right back screen. Oh, that was probably while I was switching stuff up. Let's see, are the audio levels spiking? No, those seem to be alright. Okay. So are they going to add the old Eevee render option back because they removed a lot of the old Eevee features which are useful for NPR rendering, like disabling shadows for each object is now removed? From what I know, Eevee Legacy will not be returning in any form, just because that would split developer time. I'm not sure if this will be recoverable, so I may have to load the autosave. Sorry, everyone. We'll, yeah. Since you checked the periodic option, the duplicate objects exactly line up with the original one. Okay. Yeah, I'll go and reload the autosave, which hopefully autosaved recently, because that shape was very, very interesting, and I want to keep it. Come on, Blender. Maybe it was just too many objects for it to handle. File, recover, autosave. But yeah, on the topic of Eevee Next, or Eevee Legacy and Eevee Next, it just won't, Eevee Legacy won't be coming back. The features probably will, because, you know, people need them. Like, Eevee Next lost a few features from Eevee Legacy, like with refraction and shadows and all that. Which they, from what I've heard, they'll be adding that stuff back in. Let's see, okay, what was I doing? I stored the named attribute, which I just have to say this again, having the extra space here is so appreciated. Like that's one of my favorite things about Blender 4.3. So nice. Random value, let's do this one more time. Let's set this to be a vector, put the cell ID into there, plugging that into there. There we go. Do that. Value, yep, and let's remember to set material. Set material, let's go over to the shader editor. And then attribute once again. Random, connect that to the output. Actually, let's plug that into the base color. Then we can do everything like subsurface scattering and all that very, very cool stuff. Yeah, that is very cool. I have not seen shapes like that at all in Blender before. Or even, I've never seen a shape like this even in Houdini. I wonder why. Maybe no one's done my specific brand of, like, just try stuff out and see what happens when it comes to Voronoi stuff. I've just never seen a shape like that quite before. Oh wait, no, why did I switch that to be like that? Okay, let's go back into the GeoNode editor and see what else we can do. Like, with more cells, you know, it becomes much heavier to deal with. So let's set that back to, like, 6. Even with that, it still looks amazing. Oh, wait, that was the points. I want the roughly the same amount of points, but less radial points. Here we go. But yeah, regular cells, and then they look very nice and ordered. Let's set that to be 100. Yeah, that's very cool. Okay, let's try out some of the other settings. Again, just trying stuff out. I'm not well versed in Voronoi stuff, so please bear with me. Let's see, group by edge. Yeah, we already did that. What happens if we turn periodic off with that? Okay. We get kind of just the outside parts. And with this, if we just set it to be there, the parts will overlap just because that's there. We could merge by distance, or to merge all that together. I'm not sure if that will be necessary. I have seen in order to boolean the result with the objects, you would just have to do a regular boolean. It's very good that we have that as a separate step than what's inside here, just because if you want a fast Voronoi cells, you can just do that without any kinds of booleans happening, because booleans are very, very expensive. Let's see, let me go back to the interesting shape, and then I'll go and branch this out to another object. So let's go, copy this, move it over, and then I'll duplicate that. Let's go and get another shape in here, like, let's try a torus, just to really try to make the shape, like, really stress test this, just a little bit. So we can have that. Let's just have regular randomized points in here, clean up the node tree just a little bit. Let's say, 200. The bounding box, we could just make the bounding box of this guy right here. And then in post, yeah, we'll just delete all that. We'll go and use the mesh and then do a boolean after the fact. Let's go and make sure these are correct where we get the boundary. So let's try that and let's see if I remember how to properly do that. So the difference, okay, hole tolerance, no. So there's the boundary, okay. I am seeing a few Boolean errors right there, but that's just Boolean being Boolean. I'm forgetting if there is a better way of doing that. Well, that's cool, though. That's cool. Intersect. Oh, that's very good as well. Yep. Do all that, get the insides of that, and then the boundary. Yeah, I think difference is the way to go. I forgot what was... There was an example on the developer page to do that. Unfortunately, I am forgetting that part. And here... Let's see, are there some overlaps? Let's go and scale the elements. Or wait, no, we want to... Yes, we can do that. Ah, okay, it's a little bit messed up. Maybe it's because the edges are overlapping and I need to make them a little bit smaller beforehand. In the cell fracture add-on, it would do a Boolean for each object with the main object, I think, if I'm remembering correctly. But since here the parts are overlapping, it may be causing it to freak out a little bit. So if I scale this down, maybe I'll have an easier time. It looks like it is. Oh wait, maybe, oh, sorry, I had the chat scrolled up so I didn't see the new stuff. By the way, since you checked, oh right, I've read that. Houdini also has clustering options, but on the old Voronoi node. Voronoi 2.0 does not have the grouping clustering option in Houdini. That's very interesting. I haven't played around with the old Voronoi too much. You can merge them to be cells in a for-each loop. Okay. Yeah, I will need to, I keep forgetting in these branches the for-each loop exists. So if we get a for each element, and then if that's set to instances, we can go and do a lot of that. Let's see. Yeah, maybe I should probably have the branch pulled up on the side so that I can see the node setup. Blender, Voronoi. Oh wait, that's accidentally closed out of YouTube in my browser. I did not mean to do that. Hopefully the stream is still going. Uh-oh. Are we... Yes, okay, that's still going. Good. I was afraid we lost... Wait, why do we have 60 people here? Hello, everyone, and welcome to the stream. I am trying to find the... Voronoi... Ah, there we go, I found it. Yes. Okay, where is it? Okay, yeah, so the recipe for proper Boolean with the Voronoi is to split them to instances and then do realize instances merged by distance, set position, mesh Boolean. Okay, that is a recipe. Okay. So let's go and try the recipe. So we have that. We split them to instances because we don't have a for each ID here. So 2 instances. There we go. Yep, that seems to be good. We put that in there, set this to be per instance. And then inside each one, we realize them. We set the position to be slightly smaller. I'm assuming that one's kind of optional. So we realize the instance in question, and then we do the Boolean, which again, we take the input geometry, do a intersect. Okay. Boolean, mesh Boolean, that is an intersect. We do that, and then we put that into the output, which all of the outputs get joined. So in theory, it is... What did I miss? Oh, maybe it was the merge by distance. Merge by distance. I keep trying to abridge the recipe, and what I'm learning is that you should not abridge the recipe. Set position. Same with cooking. You do not abridge the recipe. Okay, let's go and then store the cell centers as I should have done. So store named attribute, vector, centers. There we go. Named attribute, let's get vector C. Let's go and do that. Mix between the regular position. And then put that into there. So here we, okay, yeah. So when it's all 1-to-1, it freaks out, but there needs to be a little margin for that to work. Okay, there we go. There we go. I can follow recipes. I can cook. Oh, and exact. Okay, exact. When it's exact. Oh, okay. Yeah, that seems to be working. I'm guessing when it's flow, yeah, flow point precision errors lead to issues. Okay, thank you very much. Okay. So that is how you do that with a few workarounds because, you know, the for each element needs an instance input to get a group of objects. There we go. Hey, thank you very much. Okay, with that in place, maybe I'll go and copy these objects over to the rigid body dynamics branch so that we can move on to that part of the stream. Thank you very much, Tolga, for being in the chat and helping me out. Again, I have not had much time to play around with it, so thank you for the pointers. Okay, let's go and save. I think I'll save the more interesting shape, and then we'll bring that over to the rigid body branch, because there is a lot to go over with that. Let me go and, yeah, let's store all the data, so that when I move it over to the other part, we can deal with it. So, the ID for cell ID, let's make that an integer. Thanks for trying out the branch. Yeah, no problem. I like seeing the branches. They're all very, very interesting. So, and yeah, we'll do cell center, so CC, or cell centers. I should make the names bigger because we have so much space now. But, you know, let's go and do that. We'll go and connect that. Oh, wait, no, I want to keep the random value. Should I make that just a grayscale random value? Because we can always white noise it after the fact. Okay, that seems good to me. Yep, we have all that. So I will go and apply that control. Oh wait, I forget if the copy buffer works across versions. Okay, we have 65 people viewing the stream. Hello, that is a lot. Okay, we'll be right back because I'm going to be loading up the rigid body dynamics branch. Which this one's gonna be fun. Because I figured out how to get the ragdolls working with the RBD branch. Okay, let's go and open up that. And I'll put the Voronoi cells into there so that we can try turning a bunch of Voronoi cells into rigid body objects in a fast and efficient manner. If I can remember where I put that one. Where's the constraint? Constraints. Oh, dang it, I may have misspelled it. 1 second, everyone, while I get that up. But please enjoy the very well-animated loading screen, using a plexus effect that I made a long time ago. You can see that on 2 sides. The center orbiting piece... oh, dang it, where did I put that? 8 modified? Oh, please tell me I didn't delete that. That would have been very, very annoying. That is not good if I accidentally deleted it. I most likely renamed it to something that Blender does not recognize. Go down. Yep, I placed that one in the wrong direction, but that means we can just remake it, which is probably a good idea. Okay. Let's go and open that up. Or actually, wait. File, open recent. I do have that, but... oh. I was like, oh, it's in there, but nope, no such file or directory. That's because I moved it to the wrong place. Let me look it up on Windows Search. Oh wait, Windows Search is kind of useless. Okay, well, we'll deal with that another time. Dang, I should have prepared better. Oh wait, I did find it. Okay, where did I put it? Open file location. For some reason, I put it in my 2020 projects folder. That is surprising, but also not, considered how often I misplace files. Okay, I'm putting it back in the normal one, and we'll go and open that. Okay, file, open. Thank you all for bearing with me. And here we go. I just need to reset the caches. I will switch back to the non-loading screen. 1 second, everyone. Once again. Okay, should be good. So with that humongous caveat out of the way, should be ready to go in 3, 2, 1. Alright, welcome back to the land of Blender. Oh. Uh-oh, it's not showing up. Why is it not showing up? Ah, there we go. Welcome back to Blender. Okay. So here we have the rigid body physics branch where I figured out how to actually get ragdolls working, which is very fun. Look at that. In this setup, everything, including the camera motion, is driven by the rigid body physics branch. So here we can see, let's move that out of the way. This is the node setup for getting the physics to working. Getting the constraints working is a little bit funky, so I'll go over that in a bit. But yes, lots of fun stuff that we can try out. So, and also I brought this little guy over to here so we can turn that into a ton of rigid body objects. I'll go and save it just so we have that in a file, but we'll do that next. Okay. So how do we get a ragdoll to work? So let's go and make a new ragdoll. So with this rigid body physics branch, this is all done inside of geometry nodes. So a lot of stuff like setting up the constraints, the rigid bodies are done inside of geometry nodes, but they can be turned into very convenient modifiers so that it can be a little bit more like the old system. But there are a few caveats. One of them being that since this works on the geometry nodes level and not the object level, it won't work like the previous one where you just assign stuff and then you can like parent the camera to an object easily or stuff like that. It is more like, I guess, Houdini, where everything is done inside of a individual, well, I haven't done enough Houdini to be sure about that. But anyway, here you set up your world where it's like, oh, you have all the objects and all their constraints, like this object. We can actually hide the geometry node part for now because all we need are the modifiers here. The developer of the branch has made these modifiers. I did not make them myself. I did edit them a bit so that I could understand them and simplify them a bit because I think I broke part of it and then I was like, oh, let me try fixing it. But here we set up the world where we have objects. Some of them are static, some of them are dynamic, some of them are constrained to other objects, like in this case. The head here is constrained to the body there. And then here, all those parts are combined. So let's go over the process of making our own ragdoll. So let's go and make a spherical ragdoll, because that could be fun. I haven't done that yet. So let's go and make, I don't know, an object that kind of looks somewhat like a character. Let's go and do that. Let's just make a ton of spheres. This may take a little bit to do all the constraints, but you know, it'll be fun. It'll be fun. So here we go. We have a character made out of spheres. I'm choosing spheres just because we've already done squares. And then one thing you want to do is make sure all the scales are 0. Actually, I'm not sure if that's necessary, but we'll just do it anyway. And then, oh wait, we want all of these to be inside of our rigid body objects collection, because that gets ported over to our simulation, which kind of duplicates the world and then makes it compatible with all the physics and stuff like that. Okay, let's go over and actually make the rigid body physics. So here we're going to add in a rigid body modifier here, And here we're going to make the collision a sphere, and that will just automatically make it a sphere because it can match that easily. It makes it much cheaper to do so. And then we have all that. And then, well, we don't need a constraint on this one. So let's go and copy that modifier to all of these objects. Just go over here, copy to selected. Now we have all of these on here. But now to make a constraint. With this setup, I've modified it a bit, but it basically just takes the relative frames of reference matrices and all that. Download on the branch developer page, they have the example file with this. I've just modified it a bit. Oh, and also, just take a look at how many attributes there are here. I listed them all because they don't appear in the named attribute node. But there are a lot of attributes, which are very cool. I haven't played around with all of them. Okay, so in this case, once we have the constraints, you set the first body to be itself, and then the second body to be whatever it is. Now that constraint will be bound to there. And another thing I should mention, the seed needs to be different so that the constraints can work. That's another disadvantage of it being on the geometry node level instead of the object level, because we don't have the object ID, so you kind of have to set it, you have to set a unique ID yourself. Which, I think there was a branch where someone was working on object IDs, having that as an input. It would be nice to have all the object data, because I'm very greedy when it comes to data. I want all of it. But, you know. Okay, so now that we have one constraint, let's go and look at the rigid body physics sim. There we go. And we can see that it just falls. Because, you know, we only have one constraint. Since I did not randomize the other ones, it seems like some stray constraints are happening, so let's go and fix that part. So let's just go and randomly change all the seeds. Just randomly scroll them around. There we go. I thought maybe I could... Actually, I should try that. I can randomize the seed by just hashing the self-object matrix. Actually, let me do that. That might be a simplification. If two objects are in the same space, it won't work, but who cares? It'll be just fine. So if we take that and then use a hash value node. But then again, let's set that to be a matrix. There we go. So if we do that, that should make it so that all these have unique IDs, and we shouldn't have to set it ourselves. Yes, it is working. Very nice. See, I am a part-time competent at this kind of stuff. Oh wait, no, that did not work. It still got assigned to the wrong thing. Or did it? Oh no, it's still okay. Okay. Let's go and bind the rest of the constraints. I think in the old version of the rigid body dynamics, like the regular ones, you would see a line wherever the constraints would appear, and in like other in-game engines, you would see the bodies as kind of a wireframe. Those are not available now, so the bodies and the constraints are both invisible, which means that I've had to set up full visualizers for them. So if you see lines, that's probably because I made a system to kind of show the constraints. So here we can see that there's a couple, it might be a little hard to see on stream, but there's a line going to all the parts, just to show where the relationships are. Okay, so let's go and do the rest of the constraints because I've been delaying. Stop delaying and actually do it. So constraint, there we go, so we can do that. So now we have one chain, constraint. Let's go and do that again. This will take a quick second, so if you have any questions, ask them now. There we go. Whoops. Did I select the wrong object? Nope. Constraint. Now, a while ago, I experimented with a parent object node, which could possibly simplify this process. Like if objects were parented, you can just get the parent of the object, and that would be good. But my memory is fading in regards to this, but I think I was told that that would be very difficult with the dependency graph to make work. So that, unfortunately, is not an option. Okay, now that we got all the constraints working and the new hashed seeds, we can see that that little guy is now doing its job. Let's go and copy the collision floor objects. There we go, let's bring that down. We can see that the relationship lines are glitching out. I think that's because of the hashed value for the IDs. Here we can see that part's working. And I sadly forgot that all the constraints that I've just set are fixed. That's something that I forgot to mention. These can be any sorts of constraints. They can be point, hinge, and all of that. In this case, I think we'll just need point because they're all, you know, kind of... They don't need to be a hinge. A hinge just rotates on one axis, so for the wheels here, that's needed. And then for points, it's just omnidirectional. So we'll go and do that. Do points. Actually, I could just go and do that to speed up the process. Okay. Here we go. I think that should be good. And since that one is the root, it doesn't need any of that. Let's go and look back at the world over here and take a look at this. There we go. So now our character is just rolling around, having a grand old time, and all of its limbs are moving, which is very, very nice. Okay, now that we have that, that's a cool demonstration of that. Let's go and move. Oh, I'll just go and say that. I kind of started a little bit too advanced. Let's go and turn the... Which one is it? Let's go and turn our cells over here into rigid body simulatable objects. So let's go and move this over to here. And yeah, let's do it on just the same object. Though that may lag with the conversion process. Which, yeah, no, let's just have our main object and then the world. So we'll split all of these to instances because I've stored the data to instances. Actually, wait, do we need to do that? I forget if we need to. Split to instances. Actually, I'm going to simplify the process just by converting all these to different objects inside of a collection. So let's go into here. Let's try this again. Please don't crash. It shouldn't crash, you know, there's much less going on. Okay, there we go. We have a ton of objects. Oh. Wait a minute. The edges there are also split up. Okay, so let's go split to instances, and we'll actually use the cell ID and then merge by distance. There we go. We can see that's happening. Normals, let's do smooth by angle. There we go, that's looking nice. So the origin points, I'm not sure if that'll be an issue during the rigid body conversion process. We'll deal with that when we get there. Okay. I think that probably... I'm gonna turn them into objects just to take out the guesswork. Let's realize the instances now that we have all that working pretty well. Let's go and do that. And now we can go and separate by loose parts and then origin to geometry. There we go. Now we have a ton of objects with their origin centered, which I think will help with the rigid body stuff. So let's go and bring that collection into here. And let's turn this collection into rigid bodies. I have not done this before. So let's try it. Okay, so we're going to use a for each loop instead to make a rigid body for every single element here. So we're going to realize instances, and then we'll do body. So we need a wait, is it points to rigid bodies? I'm forgetting. Let's see. There's let's see, physics time steps. No primitives. We need a collision shape, which will be the convex hull of the realized instance, which is good. And now we need the... for some reason, I'm forgetting where that thing was. Rigid body, points to... Ah, there we go, points to rigid bodies. So here we need just 1 point. And then we can plug the shape into there. And then as this is output, that should give us a working rigid body for all of those, which is good. Very, very good. And then we can use a simulation zone. Simulation zone. zone? Wait. Oh, wait a second. Because I named a group simulation, is that not making it searchable? I am forgetting something. Something went awry. Because for some reason before I wasn't able to copy or add in a new simulation zone, which may be a problem with the branch that I'm currently on. Or I'm just confused as to where it went. What did I mess up? Okay, ignore that. All of a sudden, magically, we have a simulation zone. Very nice. So we need to join these bodies into a world. So we need a physics world, which this will be the automatic. This stores like the settings, like the gravity and stuff like that. In the old rigid body system, you would find this over here. So you would add a rigid body world, which is kind of just one point. Then it has a lot of these settings. Which actually, it's interesting that those parts are there. That's actually very helpful that that's separated. Okay, let's put all this into here. We just want that there. And then for all the instances, yeah, we can do that, and all that should be good. So if we then take a look at the output, let's hope this works, we'll see that absolutely nothing occurs. That's because we need to put the rigid bodies, we need to put the rigid body transforms onto the original objects here. So to do that, we can go, the simplest way to do it is to convert the rigid bodies to points, and then instance on those points. Oh wait, instance on points. If I remember correctly, there's a little issue with this, but we're just going to ignore that for now. And then we take the body state and rotation, and we do that right there, and then boom. We should have... Pick instance? We should have something working. Let's check the constraints here. Oh, there are no bodies being output. Okay, maybe that does not work. Let's take a look here. Input geometry has no elements in the iteration to... Oh, I need to switch that to instances, of course. Now we have 420 bodies. Wow, that... I wish I could say I planned that number, but I did not. Let's go and make sure that the bodies are actually moving correctly. How many shapes do we have? Okay, so that part seems to be working correctly. Bodies to points. They're all set to 0, 0. Oh, I need to take the instance position. Let's do position. Let's go and put that into there. There we go. So maybe this will work now. Okay, they're not falling, which is a problem. I have not done this for each method before, so there will be issues. Like, why on earth are they not moving? We have everything we should. We have the physics time step. We've joined the physics world. Let's go and combine XYZ. XYZ. Combine XYZ. Oh, there was nothing in there. Okay. They weren't falling because there was no... Huh. What did I screw up here? We have the bodies, we have the shapes. All of that should work correctly. So what is the issue at hand? Let's check the data. They're not moving. What have I done wrong? Do we just need another physics time step? Simulation, operations, physics time step. Actually, wait, is the simulation running? Let's go and make sure that that part is working. So let's move that up. That's not good. Maybe the simulation zone is a tad broken. Let me store a named attribute and see if that works. Sorry for the delays, everyone. But we're kind of nearing the end of the stream, so things will be winding down. Let's add, plug that into there, plug that out. Am I missing something obvious? I don't think so. Go and do this. Okay, that's moving up now. So no, the simulation zone is not the issue. So probably since I auto-generated the bodies, that may be the issue. Oh wait, no, do I need to separate components? No, I need the shapes and the bodies, so that's not the issue. So everything in here should be fine unless the 4H element zone is messing things up. All of that should be perfect. I don't want to spend too much time on this, but I feel like I have to. Something should be happening. Now I'm confused as to why it's not. Because they should be falling. Have, you know, just a value for gravity and all that. Let's go and try something else. We separate the children, so that should have all these as separate instances doing their thing. No constraints, and we have the bodies and the shapes. That should be working. Should be flawless. Let's set the velocity to be something else. So we can do velocity. And let's set that to be 1. And let's see if the time step does anything. There we go. Was it the delta time? No, it's not the delta time. Yeah, what is going on? For some reason, the velocity was just not being applied. Let's set that to negative 9.81. So, the rigid body is working. It's working now. If I just set the velocity to be the velocity. Sorry everyone, I am slightly confused. What if I just set the velocity to be the position? Okay, that separates, and now let's scale it by -1 so that they have to collide, and let's see what happens. Ah, the collision shapes are not functioning as intended. That is not great. Is that because... Oh, I think I know why. The collision shapes are not set to 0. That is probably why. So I can set the... I can reset the instance transform. Oh wait, and this that should be instances 2 points. But yeah, the shape is an issue, but we just need 1 point, and then I can input the rotation. So let's put in the rotation. Come on. Or I could just get the instance transform. Instance rotation, there we go. So I can just do that and then plug that into there. Or do I need to do that as well? No, okay. Let's go and set position, and this should work on the instance, and then combine. Yeah, this is what I get for trying things live instead of testing them all beforehand. Okay, nope, that's working. It's working. If I take both of those out... Okay, we do need the rotation, just to be sure. Should set these instance transforms to be 0. Okay, let's do this the correct way. Okay. We need to use a sample index. We set this to be a 4x4 matrix because I'm going to combine the position and rotation. And then we'll set the instance transform to be this. We do that, set the index to be the index. And then we can just go and set the instance transform. Set instance transform to be this. So here, now something's still incorrect. I feel like the bodies are not being initialized properly because they should be doing... Oh, and another little issue with this branch is that when you update values, you have to restart the cache Because if you do something... Wait. Yeah, sometimes it'll just freeze. Okay, let's set the velocity to... Wait, let's add the velocity to there, and we'll make the noise affect everything. Sorry that this was such a messed up example, everyone. That was not what I intended. There we go. But now, if I do this, we should get something a little more interesting. And then the scale will just be 1. That's a little bit much. Let's go and set that to be a little bit less. And we'll turn gravity to 0 because I do not want it colliding with anything else. Let's go and hide the original part. They're not rotating at all, which is making me think that something has gone horribly wrong. Yeah, no, something's just wrong with this. They should be... At least when they collide, they should be rotating. Okay, I don't want to spend too much time on this. Maybe... Actually, wait a minute. Why am I doing this when I could just use the node group? The rigid body node group. Sorry, everyone. I should have done that. I'll just realize the instance, plug that into there, then we'll just set the... Yeah, no, I should have done that by default. Should have made everything a lot easier. Okay. I will probably still need to set the position and all that. Center of mass. This will be a convex hull. Yeah, I probably will need to unset and then reset the data. Because, yeah, that happens. Well, that's cool, though. So, for the bodies and all that, I will need to... Or would this work on the instance domain? I do not know. Let me look under the hood. Collision shape from geometry. Oh, no, it just takes the geometry and then does that. Okay. So I realized this. Oh, that's cool. Unintended, but cool. Let's get the instance transform. Transform. We'll get that, and then we'll just set it in post, but then that won't affect the bodies correctly. Alright, no. Okay. Transform geometry. Let's set this to be just the complete package here. Sorry, everyone. I should not be doing all this debugging live. We want to invert the matrix to reset this to 0, and then we're just going to set the transform for everything, which I hope affects the bodies. And then I should probably realize the instances after the fact. There we go, okay. Are they rotating, though? Or are we back to square one? Or is the transform geometry not working on the bodies? You know what? I think we'll save this for another day. I've spent way too much time on this. But you can see that if you set... Let's do this manually. Yeah, that'll be fun. Let's do this the manual way, because unfortunately I am not well experienced in this part. We'll set the realized depth to 2, just because the way that that's all set up. And we want to separate the components, which will be the physics bodies. And then, whoops, I did not mean to do that. And the instances, we'll just set the transform after. I know this is looking very hacky, but since apparently I have done this very incorrectly, we'll deal with it. Oh no, that's... Sorry everyone, I was being a little bit dumb. I just realized what's wrong. All of you in chat probably knew it from the second I was doing all this. But since I converted the bodies to points, the body motion just was not applying. Sorry everyone, I was being a little bit stupid. For each element. There we go, let's do this properly this time. So let's get the instance transform. There we go. Let's do this the right way. Let's get rigid body, rigid. Nope. Muscle memory working against me big time. There we go. We get all the instances. Yes, let's make sure we do this correctly. We will transform these instances. We're just transforming the entire geometry. We'll invert that to reset it. And I will realize the instances as they are put into the rigid body system. Then I will transform the geometry again so that they're put back into the place they should be. There we go. And now, yes, point domain, that is good. Very sorry, everyone, but at least we're getting there in the end. There we go. Now the rotation appears to be working. I spent way too much time on that. Though it does look like the bodies are still being reset to 0, which is unfortunate. So, how do we... I can just set the body position to be there. Like, this rigid body system is not necessarily built for that. Okay, let's do that. Let's do, points to bodies. Yeah, let's do this. Yeah, okay, yep, we can do that. Let's do this with the fewest amount of nodes and node groups possible. So it took us 30 or so minutes, but we're getting here. Okay. Points. Let's do that. We can we already have the instance transform, so we can separate the transform and then set the position and rotation to be there. And then we need the shape. Shape info, shape bound, shape geometry. Wait. I actually need to look into those. Okay, so collision shape. Buddy, work with me. Let's do convex hull, and we put that into there, and then we put that into there. There we go. So unless I need to set the point position, like, I'm not sure if that part's redundant. Might be okay. Should see something beautiful. Beautiful. Okay. Took way too long. I apologize for that, everyone. Maybe I'll edit this part out of the stream when it goes up, but, you know, maybe seeing my weekend brain debugging the process, maybe that's educational. Who knows? But there we go. That's how you turn a ton of instances into rigid bodies using this branch. And okay, let's set instance transform. We'll set this to be... The music just changed. Oh, I forgot I downloaded that from... Let's switch that back to the Zelda music. I've been looking at different tracks since the YouTube copyright strikes have been happening. Let's make this a combine transform. I forget, is that a identity matrix by default? I forget if the default is just the identity matrix. No, it does not appear to be so. I don't know why that's freaking out now. Maybe transforming it was the right way to go. Oh, wait, and I need to realize after the fact. So if we do that, okay, that works. And that does not work. So I do have to have a default matrix in there. Okay. Okay. So that is the way to do it. Whew, there we go. There we go. It is nice to see that the for each loop came just in the nick of time to do this in the rigid body dynamics branch. Okay. Whew, with all of that out of the way, let's go and add in some more shapes. So since we have this setup, we can add in whatever instances we want, and they'll just automatically be converted into proper convex hulls. So let's go and put in a cube as the ground plane. Cube. And let's not forget that we need to port all this over to there using a very long line. There we go. So once I get a better grasp of this, because my grasp is not that great at the moment, I'll be looking into making just a modifier where you just point to a collection and then it'll simulate everything in like 2 clicks. That's the goal, isn't it? Have a setup in 2 clicks that just works. In the famous words of Todd Howard. Famous words of Todd Howard. There we go. So since we are making... This is very messy. I apologize, everyone. Let's take a little bit of time to clean all this up. There we go. We're just going to go and do this. So we'll have the different stages right here. I'm not going to turn them into groups just yet because I still like having all the stages not nested. This nesting can be a little bit annoying, but then again, this setup is not exactly great. There we go, Control J. So we have the convert instances to bodies. So instances to bodies. There we go. And then we have the RBD sim. And then we put the RBD stuff back onto the instances. To instances. There we go. Very, very nice. Okay, now let's go and add in that cube. And we need to turn that into an instance. Or no, Geo2 instance. Geo2 instance. There we go. Let's go and make a nice cube before everything gets simulated. And this will be, I think it's lagging because... There we go. Let's have that, and now let's go and... Now I want to set that to be a static body. So, maybe I'll just store an attribute which is static, and then we'll just port that into there and call it a day. Or, let's see, set body activation state. No, set body motion state. Nope, set body motion state. Set motion type. And that'll be static only to the selection that we choose. So we don't even need that inside the for each loop. No, we do need that as a for each loop. So we'll set this to points, instances to points, so that it'll keep that data. So the rigid bodies will keep all the data that we specify, which means that we probably don't need that in there, but I'll just keep that in mind. Shape, and the shapes are accurate, correct? And that's set to stack. Okay. Sorry for all the delays, everyone. We're finally getting there. My grasp of this has been very weak. Let's just do is static. There we go. We'll set that to be true. For everything else, it'll be set to false. So we'll just go named attribute is static. We'll go and set that to be there. There we go. So now, as that goes along, we'll see that the body here is static, and we'll go and let the gravity do its thing. So here, there we go. After all this time, we can see that we convert a rigid body into a collection into rigid bodies, and then the rigid bodies just work. We can go and make the noise do what... Oh my god. Sorry about that. There we go. We can have them be affected by noise and all that cool stuff. Sorry it took so long, but we got there in the end. Let's set the ground plane to be 100 by 100. And then there we go. We can do that, and then we can have empties affected and all that cool stuff. There we go. The velocity, that wasn't too bad. It was bad, but not that bad. I just need to figure out why everything was going wrong. Like, changing the instances to bodies, that's not a bad setup. And timing. How much is the timing? 44 milliseconds. Okay, since it is a pre-calculation step, that is okay. I wonder if the cell ID from the Voronoi could be used for the constraints later. Potentially. In this case, actually, I think we should be... It needs just a unique ID per body. And the issue... I should elaborate on the issue where we needed a random seed per one. It's because we don't have access to the body index just in Blender. So this object does not know what collection it's in, at least geometry node wise. It doesn't know what collection it's in, it doesn't know what its index in that collection is, or index just in Blender is. So it doesn't know if it's unique or not. Like, if I didn't manually set this data, it doesn't know it's unique, besides the position data, which we've exploited. But as soon as you reference the collection, it knows. So it knows the indices of all those. The difficulty with this is that since you set the constraints to be the bodies, you're referencing a body that doesn't have data for what it is. Besides, again, the location. So if the location of this body that it's referencing is the same as this one, it knows that, okay, I'm linked to that. So it just needs a unique ID. While in our sim situation here, they do have unique IDs, so that part is okay. So if I want to set some constraints, which let's go and try that out, this may horribly backfire. Okay, how do we do this again? Let's see, constraint. With the constraints, physics constraint, there we go. I have noticed that there might be a bug when it comes to the bodies here, because I've tried setting that in data manually and it freaked out a little bit, so I set it as a named attribute. The bodies are on the point domain, at least in the physics component. That may change in the future. I think at the moment it may be a placeholder. While the physics constraints are viewed as edges. So here, if you want to set like the body index, like it just needs to know what's the body relation, then what is the relative matrix transform, the relative transform to it. If I'm correct, which as we've seen so far, I may not be. There we go. So we have these right here. And we need to set some constraints, because right now this is set to be -1, so no bodies are being constrained at the moment. So I'm just going to make it so that these are random, which is probably a bad idea, but oh well. Random value, we will make it so that every single... Well... We'll make it so that every single edge is linked to a body of the same index, and then they will all reference just one body. So we'll just have an integer, which will be 0. So if we look in the spreadsheet, I need to make sure that this is working. If we look at the constraints, we have 25 of them. Let's go and look through the data. So this is what I was talking about. For some reason, the bodies don't really seem like they can be set. I'm assuming that's a bug with the current branch. Again, the branches that I pull are not like the super official ones, so I probably got one that was being worked on. So as we can see here, the bodies are still 1, even though... let me just make sure. Yeah, they're both 1, even though I've set them to be that data. So what I need to do is I need to do it manually. Or not, I say manually in the sense that I need to store a named attribute that's an integer on the edge domain, which works because we only have physics components in this setup. And this one will be body1. Let's look at the name again. Yeah, body1, body2. And then, as far as I know, we may need to set the body transforms, yeah, frame 1 and frame 2 by ourselves. But we'll see. So if we set body1, and body1 should always, if I'm correct, be the self body. So if we do this, and then set this to be body2, we should see, once we reset the cache, that the numbers, there we go. We can see that the numbers are aligning. So just keep that in mind. In the one that I'm doing, those inputs are a bit broken. Okay, so now that we have that, let's go and connect back to the output. We should see that these bodies are doing nothing. Okay, what did I screw up? What did I screw up? Is that the frames are incorrect? Potentially. Let me set this to be random so that they're all bound to random. Okay, no, that is working. just causing some issues because they're trying to clip into themselves. So in this case, what I need to do to set the frames correctly is I need to go and store 4x4 matrices on the edge domain, referencing the either the instance transforms or... Would it be better to do this inside the for each loop? Nah, we can do it outside, so let's do it outside. So we need frame 1, which should be the self-transform. So that one we can leave as 0. Then we need frame 2. So we technically don't need to set this one because that can just be the self-transform. But we need the relative transform from one instance to another. So I will screw this step up, so keep that in mind. I need to get the instance transform. I need to sample the self-instance transform, and then... Sorry, 1 second. My brain needs to cook just a little bit. So I'm gonna not do this on the body state just because I want to... Yeah, okay. Let's use the sample index. So we want to sample the body 2 index. Or no, we want to sample the body 1 index. Because we're trying to get the matrix offset between one and the other. So we want this, and we want to sample the 4x4 matrix. So we want the instance transform. There we go, instance transform. This will be on the instance domain. So I want to compare this instance transform to the... Yeah, okay, no, this will work. Body 1 and then body 2. Okay, we're gonna get the transforms for both body 1, body 2, and then we'll compare them. If I'm way off base, please let me know, but I think I'm headed in the right direction. We get those, and then we want to invert 1. Invert... Wait, sorry. Invert matrix. I don't know why... Oh, I said that to... there we go, yep. I think I've been streaming for a little bit too long. Let's go and multiply the matrices. I forget which order this has to be in, but I think it should be like that. Go with this. Actually, for some reason, it doesn't look like... They don't look fixed. So why... What am I missing? Frame 1, frame 2. Maybe the bodies are just very far away. Oh, no. Oh. Body 1 and body 2, and that's just the... Yeah, no, that... The indices should match. And we get those, and then that should work like that. Yes, I am way off base, everyone. But you probably could tell anyway. Well, that looks solid. How come... Something's very messed up with all this. Because those... They should be falling, but they only fall when the velocity is actively updating? I think I messed something up. Yeah, because I added nothing. That... Wait, what? If I set this to be 0.001, then gravity works. I am quite confused. Let's set the constraint count to be quite high. Okay, we can see that the constraints are trying, but yes, I do have this screwed up. So maybe the constraints are just not working because I screwed it all up. Probably. Let's set this to be 420 because there's 420 bodies here, and they'll all be constrained to one object. So, as we can see, the constraints are trying to work, but they should not be moving like that. So I have this set up completely wrong. Transforms... Maybe body 1 should just be frame. It looks like it's trying, but I still feel like it's wrong. It really is trying, isn't it? Okay, we'll save that for another time. But you can You can see the kind of workarounds I've had to do because of, you know, the setting the data bug. But I'll save that for when I know what I'm doing, which may be, you know, a couple weeks from now. Okay, here we go. Let's see. Still early dev, but the potential seems gigantic. Houdini stuff. Yeah, like if, with this, like what can we do with this if we just had this rigid body data? Well, for one thing, I could make it so that every body has a trail by using the trail setup that I made a while ago. I can make it so that particles appear when all, you know, when the bodies fall. Actually, I don't know if there's an attribute for when there's a hit. I know the developer mentioned something like that, like maybe getting the hit points and stuff like that, but I don't think that's available at this time. But yeah, lots of very cool stuff can happen. So I guess I'll leave you all with all of these being attracted to an empty. So subtract, because yeah, we're almost at 2 hours. I've been streaming for way too long, but you know, this is a big day. Cool stuff is happening. Let's scale this down, and maybe I want to set the range, but no, let's make it kind of wacky. So here we'll make it so that the velocity is 1/10. The closer it is, the less force. The further away it is, the more force. So here, all of these are trying to... Oh yeah, I need to try this with like particles attracting to like a human shape, so I can make a man made out of rocks. Or it could make like a Sandman thing, but then again, no. The Sandman thing would take so many particles that I might as well just do something simpler, like a point-based method. Even though, with I wonder how expensive spheres are compared to my method, because the collisions would be more accurate. So here we can see that... There we go. They're all trying to get there, and maybe I should tone down the velocity by a bit. So they go there, and then they eventually settle. But then, as they start to settle, the amount of vorticity goes up. So we can see that they're all trying to join together, but they keep absolutely freaking out. Let's make it a little more... Okay, that was a bit too much, you know. A bit too much. There we go. Let's tone down a bit more. There we go. So now they're all trying to move. Let's turn on some nice motion blur, and hopefully it doesn't make everything freak out. Yeah, no, that looks okay. It's trying. But now we have a lot of moving rigid bodies. All are looking pretty good. We're moving over the surface, and it looks alive. I would say, even though there were many missteps along the way, it's pretty good. On my part. Like, this branch is absolutely incredible. As someone who has tried to make a rigid body system from scratch inside of geometry nodes, it was incredibly difficult. But we got close. With help, I got quite close, to the point where the only part that was missing was accurate contact points, which unfortunately I don't know how to do. Unfortunately I don't know how to do that. Because you need to compare the geometry to all the other geometry, which maybe we can do with the 4H element setup. But also, you need to, like, prune the points a bit so that you don't have tons of... Yeah, it was difficult. But now that... Oh, and by the way, I should mention, this is using Jolt Physics. The Jolt Physics engine, which was... I think created for the Horizon Zero Dawn game and used for other projects, but that is like semi-open source, so that's being used. The creator of Bullet has recommended the Jolt physics system, which Blender, the old rigid body system, uses Jolt, which it works very well, but a newer system is appreciated. Reminds me of Avatar Earthbending. Well, if this works out, that maybe we can do that. But we can do that. This gives us the opportunity to just have collisions, which is very nice. Like, just the ability, like, this doesn't necessarily even need to be simulated. Like, if you have a setup where you need parts to just not collide, you can do that. Like, you can have this with a repeat zone. Like, yeah, let me do that. Repeat zone. Physics, yeah. Why did the simulation zone not appear? There's group simulation, unassigned simulation, and then group simulation. And then I'll have my custom things. But for some reason, the simulation zone is not appearing in this part. So maybe that's another little quirk with the setup. So here, if we just replace this with a repeat zone, we can make this run, and the delta time will just be set it to be the default. Here, if I... And that's why we simulate it instead of doing that, because it gets more expensive every single time you run it. But if you did this correctly, like a while ago, there was a physics add-on where you can just place stuff in your scene using rigid body physics, which was very cool. I would recommend that. Oh, this isn't recovering, is it? Okay, I will reload the autosave. 2 crashes today, both self-inflicted, which isn't too bad. Let's go reopen it. But yeah, having the ability inside geometry nodes, even though it has some constraints, compared to the object-based system, it's still very, very good to have, because it could be a very useful tool, even for stuff, you know, not like, there we go. Yeah, see all that? That's very nice. It can be used for stuff even beyond the standard rigid body, oh, a ton of fractured things falling. Like, I could probably use my plexus setup to create the... If I can figure out the constraints, I can make an auto constraint generator so that I can create like a wall that has, or turn, yeah, if, you know, if you want to go super advanced, using the Voronoi fracture system to fracture a building, have a setup to turn them all into rigid bodies with constraints, and then boom, you have a geometry node setup that turns a building into a fracturable object with constraints. That is fully possible with the building blocks that we're getting. So yeah, it's the future is very bright for geonodes. And then if the volume, there are the like volume grid nodes that are still experimental, which that they said are the building blocks for, like maybe you know, thinking optimistically, maybe fire simulations. So we're getting building blocks to potentially make Houdini-esque stuff inside of geometry nodes. Now, Houdini will always be better. It always will be when it comes to physics simulations and stuff like that. So the question is, why do this stuff in Blender? Well, for quite a few things in my work, I use Blender quite a bit. And it's very convenient to do this kind of stuff in Blender rather than switching to Houdini and stuff like that. And also, if you don't want to pay for Houdini. But yeah, having this in Blender is always very good for things that need to be inside Blender, because some projects do need to be in Blender. Sometimes you can't just export an Alembic with everything you need. Most of the time you can, but you know, there's sometimes. Sometimes you just want it all in a program you're familiar with, which is why I'm so excited about geometry node developments. Okay, we have 2 minutes until 2 hours. So I think that's enough for today. Thank you all for watching. I hope you all enjoyed. This was very cool, looking at all the branches. The NPR branch is looking fantastic. The Voronoi fracture is looking fantastic. Thank you very much to the dev in chat for helping me through that. And the Rigid Body Dynamics branch is looking amazing. If it gets I should also mention, these branches are experimental. They may not be in 4.4, they may not be in Blender in 4.5, 4.6. They are experimental. But they are very successful experiments, I would say. So I would be happy if they got joined. But for now, they are very cool branches. And at the moment, I could use these for a few projects that I'm considering. So having the branches is very good. Just have something in a pinch. So, yeah. So thank you all for watching. I hope you all enjoyed. And I will see you all next time. Have a good one.